Now, in this slide, I'll be talking about the resultant forces that influence wind direction. So before we discuss in details of the three of these forces, we have to understand Newton's law of motions. Our understanding of why wind blows stretches back through several centuries, which many scientists contributing to our knowledge. When we think of the movement of air, however, one great scholar stands out, Sir Isaac Newton, who formulated several fundamental laws of motion. So Newton has the first law of motion stated that an object at rest will remain at rest and an object in motion will remain in motion and travel at a constant velocity along a straight line as long as no force is exerted on the object. For example, a baseball in a pitcher hand will remain there until a push or a force act upon the ball. Once the ball is pushed or thrown out, it would continue to move in that direction forever if there were not for the force of air friction or force of gravity that can pull it towards the ground and catcher which exert an equal opposite force to bring it to halt. Similarly, to start air moving, to speed it up, to slow it down, or even change its direction require the action of an external force. This brings us to Newton's second law. So Newton's second law stated that the force exerted on an object equal its mass time the acceleration produced. We can say F is equal to ma. F is force, m is equal to mass, and a is equal to acceleration. From the relationship, we can see that when the mass of an object is constant, the force acting on the object is directly related to the acceleration that is produced. A force in its simplest form is a push or a pull. Acceleration is the speeding up, the slowing down, and or the changing of direction of an object. So more precisely, acceleration is the change in velocity over a period of time. So now let's come to the real point. Because more than one of the forces may act upon an object, Newton's second law always referred to a net or a total force that results. So we call it resultant force. An object will always accelerate in the direction of the total force acting on it. Therefore, to determine in which direction the wind will blow, we must identify and examine all of the forces that affect the horizontal movement of air. These forces includes number 1, pressure gradient forces, number 2, Coriolis effect, and lastly friction. So in the coming slide, we will going to talk about the pressure gradient force Coriolis effect in details.